Welcome you to our Analyst Angle webinar that's being hosted by RCR Wireless and being run by Strategy Analytics with panelists from InterDigital and BT. And our topic today is network slicing, the key that unlocks 5G revenue potential, where 5G meets SDN and NFV. So today we'll be starting to talk about 5G network slicing, a game changer, and I'll be doing that part. My name is Susan Welch-de-Grimaldo. I'm a Director for Service Provider Strategies here at Strategy Analytics. We've got next after me a discussion of opportunities and challenges ahead with Maria Cuevas, who's the head of Mobile Core Network Research at BT. Then we'll have Technology Options for Network Slicing by Akbar Rahman, who's a Senior Principal Engineer at InterDigital. Then I'll turn it over to my colleague Sue Rudd, who's a Director here as well at Strategy Analytics, and she'll be discussing some of the current examples we've been seeing of network slicing solutions and how it's progressing in trials. Then we're going to break for a panel discussion internally among the panelists here to dig into the challenges and where to focus in 2018. And after that, we'll have some time, hopefully, for a bit of audience Q&A. So there is a Q&A box, which is where you will be able to present this. And after this, everyone will have access. We will make these slides available as well as the recording. So some of this might have a lot of details, so you'll be able to go back to that. So end-to-end dynamic network slicing in 5G. Really seeing this as holding the promise as the key to unlocking new business opportunities with 5G to drive revenue growth. So a lot of operators are really thinking through what is their investment strategy for 5G, how are they going to make a return on investment? And slicing is something that, although we can do some of it in 4G, what really gets enabled in 5G is really that key to unlocking this business. So to start off with just a couple quick definitions, pretty basic. There's a lot of great research and material out there. I encourage you to search for that if you don't know much about network slicing. But one definition I found I really liked is that network slicing segments one big broadband network into multiple virtual networks to serve verticals and applications in a more cost-efficient manner. And that's from 5G Americas in a white paper that they put out. Dynamic, we're talking here not just static slices that get set up and stay the same, but ones that can be spun up and spun down as needed, pulling different resources in. And we may see different slices attached at the same time to a particular end user equipment. End-to-end, here we're talking about this not just in the core, but across the whole network from the connected device or the user equipment. That could be through radio network or other access network, backhaul, crosshaul, edge compute, which will be a key part of this, core networks, etc. And we'll see different types of ends, and these ends may be moving around, so it's going to be a challenge there to do that, but that's really the goal, is to get end-to-end with this network slicing. And new business, we're talking here. Some things will be things that we can deliver today with 4G, or maybe doing somewhat, but they might be enhanced with 5G, as well as new services that have not been enabled before and will be something new to help drive revenue in 5G. So we're really seeing 5G network slicing as a game changer because it designs the network for service agility. This is a real service paradigm shift. We're now seeing network slicing as a way to integrate services with the network end-to-end and design from the beginning a network that has this service differentiation as part of it. And as you're all familiar with the little diagram here with the different types of use cases and categories of use cases, from enhanced mobile broadband, massive machine type communications, and then the ultra reliable and low latency communications. These all will be served through one network with these virtual slices, enabling different types of specific quality of service for these particular use cases or for different customers who may have specific demands. One thing we see is that this enables new types of services and business models. In particular, network as a service, an ability to have new types of virtual operators or partner models to serve particular verticals or specific segments with use cases. And these can be designed for performance, improved performance, as well as cost efficiencies. And we'll really move to a model here where services are thoroughly integrated with the network rather than sitting on top of the network. And as you all may realize, as we move to 5G, who is offering services and how services are packaged will shift. And we may see some new business models, new partners, new players, certainly a lot more integration with other ecosystems that need to really take a role in designing this end-to-end network. So now I'd like to hand it off to our operator who's on the panel talking about network slicing opportunities and challenges ahead. So Maria Cuevas.
Thank you, Susan. Hi, good morning, everyone, and good afternoon. So I was going to talk about pretty much the opportunities and the challenges that we see on this new technology. As you've already heard from Susan, a very high-level recap on what network slicing means to us is that it enables operators to deploy multiple logical networks dedicated to the needs of different services over the same infrastructure. The picture that you can see on the right-hand side has been taken from an NGMN white paper on 5G, which describes what are the upcoming needs that we expect to come from different vertical markets and how we expect network slicing to address the needs of a very wide range of vertical segments, including massive IoT type services, autonomous driving, or just mobile broadband access, amongst many other service types. Into the main area of the conversation, and we've done quite a lot of work internally in BT and with our partners to figure out what opportunities this new technology may bring to us. We categorize the advantages or the opportunities of network slicing into three main types. On the first hand, as Susan already mentioned, to us is absolutely crucial that it enables rapid deployment of new services. We need to make sure that when we deploy a new service or we modify an existing service, there is no disruption to the existing ones. And that's key for us to be agile and be able to compete and meet the needs of the market. We absolutely believe on existing capabilities like network function virtualization and software-defined networking being key technologies that will enable the orchestration across slices. And the end goal is to have a fully automated deployment of new network slices in order to meet market demands. The second main category of opportunities comes from the ability to support different operational models. That's hand in hand with, again, being able to meet the needs from the market. We believe that network slicing will enable us to deliver service level agreements of many different types, including different security, reliability, and functional requirements, and that will in many cases require isolation between different slices. And we believe that slicing and the number of slices that we deploy over time will increase and will be in some cases able to meet the needs of a group of services, and we may deploy a slice to meet the needs of a particular service type. But in some cases, and as the technology evolves and matures, we may be able to deploy slices for individual customers. And the third type of opportunity that I would like to touch upon is the ability to support conflicting functional requirements. We believe that with the increasing demand and the wide range of customers that we may have on our networks, there may be functional requirements which are actually mutually exclusive and therefore cannot be supported by the same functional instance. That's where we believe the ability for network slicing to give us a virtualized, a separate slice across our network will enable us to deliver the needs of the different services. There are some examples here, including, for instance, the ability to meet high data throughput requirements versus potentially low latency or high mobility versus fixed access to our services. And not only the actual exclusiveness of the functional requirements, but it's very important that we are able to support those in the most optimal manner. And again, optimization and efficiency to us are very important and a very important aspect of network slicing. Another thing that I would like to mention on this slide before we move on to some of the challenges is that, as I mentioned earlier, we're doing a lot of work with a number of partners in this space. We have actually demonstrated capabilities of network slicing publicly with partners like Huawei. As you can see in the picture, we've been actually testing isolation capabilities on network slicing to make sure that we can meet the needs of the different services. We've also recently published a report with another panel of ours, Ericsson, in this space, looking at the techno-economics and what we see as the main benefits of network slicing. If you would like to move on to the next slide, please. Susan, can you move on to the next slide? I'm not sure. Susan? Sorry, could you click onto the next slide? Or Kyle? Right, I'm going to have to move on. you'll see in a minute. Okay, it will appear on the screen hopefully. But I wanted to talk about the challenges around network slicing. For us, the challenges are not just technical, but also, thank you. But I would like to actually start from non-technical challenges which in our view are coming from organizations and culture in the existing telecoms market. They also come from the operational aspects of this technology, and I'll talk a bit about that. And finally, I will also touch on some of the challenge that we see to achieve this technically. So from an organizational perspective, we believe that the cultures in all the companies involved, not just telco operators, but also obviously vendors and even the customers in this ecosystem need to evolve. As an industry, we need to become a lot more agile and a lot more rapid in the entire life cycle of a service. It's really good that the technology and a technology like network slicing will expedite one aspect of the delivery of a service, obviously, which is actually the technology itself and the implementation. However, the entire concept to market includes many other steps in the process. We believe that the service definition, the approval of the business cases, the selection of the technology, the design, and even the way we trial services with customers need to be expedited. We would, of course, expedite the delivery process using network slicing, but as I said, every part of the value chain needs to be much faster than it is today. In hand with that, we need to adapt our business models. Okay, we expect with network slicing a wider range of business models starting to appear, and the number of stakeholders in the ecosystem will also increase dramatically. And that will include multiple operators in the chain. It will include multiple administrative domains, and will include many technical capabilities in the end-to-end system. And that will make these new services very complex to deliver and require increased flexibility and agility by all parties. They will also require commercial agreements that include well-defined and strict SLAs by all parties. On the other hand, moving on from the organizational aspects onto the operations, we believe that network slicing comes at a cost. Okay, and this is the potential complexity of running multiple virtual networks instead of running a single network, which is what operators have done up until now. In principle, technologies like NFV and SDN, as I mentioned earlier, will help manage that complexity by ensuring, for instance, a common operational model for the underlying infrastructure or the underlying transport resources. However, we strongly believe that as the number of slices increases in an operator's networks, there is a need for tools that allow for autonomous management of slices. And that's not just about the creation or the deletion of a slice, it is also about the scaling of the slice throughout its life cycle. It is about service assurance, about fault finding, self-repair, and applying emerging technologies like data analytics, machine learning, or artificial intelligence to not only repair but also predict the demand and the network behaviors and even faults in the system. At the end of the day, we need to make sure that the cost of operating these multiple virtual networks doesn't exceed the additional revenues that we're expecting to get from those services. And finally, of course, there are technical challenges. And we know that there is a lot of work in industry and network slicing, and Akbar is going to mention a number of activities in that space, and also Sue at the end. And there is a lot of debate, obviously, and activity in standard organizations. However, we feel there isn't enough work or emphasis on a true end-to-end view to network slicing. And at the end of the day, that's what makes the real difference. And network slicing will help operators ensure an end-to-end SLA to their customers. And if that is not going to be achieved if we're just looking at slicing in the 5G core or just looking at slicing in a transport network. We really need to take a holistic view of the overall ecosystem. So we need robust and consistent mechanisms to slice all segments of the architecture, including the radio piece, which is currently very immature, but also we need mechanisms to bring all of those sub-slices together. And that means orchestration across multiple technologies, multiple administrative domains, and we may need to compose a slice out of multiple sub-slices, and potentially those sub-slices may be in turn composed of other sub-slices. And that's what we call recursiveness. At the end of the day, this is a topic that is starting to become very relevant, and that's the question of how operators will describe the capabilities of their own slice. This is particularly important if an operator is trying to sell their services or their slices to a customer, or potentially to set up a roaming deal with another operator. So we believe that there needs to be a common way of describing to others what we have in our slices. And by the way, that's not necessarily about standardizing a set of predefined slices, which may happen later in the process. It's about generating some form of template we believe that operators can use to describe what their slices can do in terms of performance and functionality, and what they can provide to other organizations. And we're working with organizations like the GSMA, who we believe have a critical role to play in making this work for industry. If you would like to move on to the next slide, please. Thank you. Finally, this slide is touching on some of the points that I have already mentioned. It pretty much is a way of showing what we mean by true end-to-end slicing, and believe me, it could get even more complex than this. From left to right, we're showing here how, obviously, as traditionally we have always done, and we will do in the future, we would have cell sites with radio equipment, and that could be sitting, obviously, on a public domain or a customer premise equipment. And as we mentioned before, we need flexible and dynamic allocation of radio resources, and we believe this is key. We all know radio is a scarce resource, and we can't afford to perform a hard allocation of specific radio resources to a specific service. Therefore, we need complex schemas and solutions for a very efficient sharing of the radio resources that still allows for the appropriate level of service assurance to each individual service and each individual slice. In addition to radio resources, in some scenarios, we will also need to deploy some user plane functionality on the customer side or at the edge of the network, or even applications that they may need to run locally. And this is to ensure, for instance, low latency can be delivered, or even access to local content. These capabilities at the edge of the network need to be managed by the operator as part of a slice. As we move towards the right, another point I made earlier is the need to traverse multiple administrative domains. Often, both front-haul and backhaul resources may be provided by third-party network operators. And there is a need to integrate those sub-slices into the end-to-end picture. As we said, this needs to be done recursively. We may need sub-slices across different domains that we can compose to form end-to-end slices. And subsequently, sub-slices maybe have further subcomponents within them. This is a concept that needs to be built into the models of how resources are consumed in this architecture. We also think that some of the SAM slices or the functions will be shared across slices. We already know that functions in the 5G core, like network slice selection, are meant to be shared, but there may also be other functions like user data management or policy control, just as examples, when appropriate, which may be shared across slices. That means that those functions need to be scaled accordingly and dynamically managed as a shared resource across the slices that make use of those functions. There will be cases where customers want to deploy their own functionality, for instance, if they are running their own MVNO models, and others where the application logic may reside in the customer domain. And we need to make sure that the way resources are allocated in that domain is included into the end-to-end picture, and very importantly, into the end-to-end SLA. Finally, before handing over to the next speaker, bringing up the bottom of that picture, we would like to emphasize the need for an end-to-end orchestration and management domain that makes use of some of the upcoming technologies in areas like machine learning, artificial intelligence, fault detection, self-healing, and so on, to make sure that we can build the right level of automation and we don't necessarily increase the cost of managing these networks because they can become very complex. So that's my slot, and I would like to hand over to Akbar, who is going to describe some of the key technology options for network slicing.
Okay, thank you, Maria, and hello to the audience. So as Maria and Susan mentioned, I'm going to be talking sort of the technology view of network slicing. Specifically, I'm going to be looking at it from the Internet Standards perspective that the IETF SDO Standards Development Organization that I participate in. So let's just dive into it. Next slide, please. So the first thing that is often said during technical discussions, either in standards or in conferences, etc., about network slicing is that the actual problem space seems familiar, because this question of slicing the network into different sections, paths, pipes, etc., we seem to encounter it, let's say, every new generation of technology. So in the past, of course, we've had virtual networks, VLANs, VPNs, some of them at layer 2, some of them at layer 3, but definitely this concept of virtual networks is not brand new, so it's been there. Related concept, the quality of service, SLAs, etc. There have been a lot of standards, products developed that provide you a good QoS control in the network. So that again is something that we're already familiar with. And then of course virtualization, maybe from the telecom point of view, it's the newest. We have NFV, NFV, Mano, etc. All these different parts. So the first bootstrapping question that is often asked during technical discussions is really, do we have to reinvent the wheel? Why can't we use the existing functionality? And what is it really that's new for network slicing? So that's what I'm trying to. That's what I'll try to cover in the next few slides and try to give you some insight. Next slide, please. So just to repeat the definition, because it's always good to have a basic understanding of what we're trying to achieve. So network slicing involves allocating a customized virtual slice of computing, storage, and networking resources at an end-to-end IP network level for a given set of users. Let's use the word tenants, as the data center people do, as the cloud people do. I think it's a good description. We want to be able to give a customizable end-to-end slice of the network for a generic tenant, or any tenant that might want to deploy a specific service. We should be able to customize the network to meet their requirements. Now, if we compare against in a little more detail some of these previous solutions, the VLANs, I think that's probably what technology people are most familiar with. VLANs are layer 2 abstract concepts. So basically, they're layered on a layer 2 LAN solution, and the first problem we encounter, of course, is that it's not layer 3, because the network slice that we're talking about, really, we want to encompass the IP layer and make it end to end. So the VLAN, first of all, it has a shortcoming in the solution space in that it's layer 2. And another very important problem with VLANs is they're really targeted for the networking component, not the computing and storage. So we can see right away there that the VLANs directly will not serve the purpose. Then if we look at QoS approaches, quality of service approaches like DiffServ, DiffServ is really well deployed in IP networks all across the internet, in enterprise networks everywhere. And it does a good job in the networking component, so it basically prioritizes different streams of IP traffic and gives different delays, etc., and characteristics, SLAs. But it does not really address the compute and storage of resources. So again, that existing solution has a shortcoming. Next slide, please. Now, of course, the latest and greatest approach is NFV. It comes from the ETSI SDO, and basically the component that we're most interested in is what's called NFV Mano, the management and orchestration component of NFV. And NFV, by definition, it does take care of compute, storage, and network resources. So that one problem that the other solutions have is covered by NFV. But if we look specifically at what are the gaps that NFV Mano has that don't meet the solution for network slicing, the first we see is that NFV Mano is not really well suited for making customizable requirements. So if a specific network slice, for example, needs a specific encryption technique, or needs very high isolation parameters, or needs to span administrative boundaries. For example, a network slice going between two operators for a national smart grid. if you look into the details of NFV Mano, you'll see that the standardized solution doesn't really address those components. They address a lot of other components. It's IP based. It handles compute, storage, networking resources, but it doesn't solve all the problems of network slicing. And another, I would say, even more fundamental problem is that NFV Mano, it can put together virtualized components of a network, but of course, by definition, it's not actually providing you the underlay network itself. It's just you can configure it together. So if we look at network slicing, some of the use cases that are well described, for example, for the vehicular control, where you have very, very low delay requirements because it's a safety issue. You know, if you have to stop a car that's going at high speed near a light, the delays are very, very stringent, and there's not much leeway there. So the other thing that when we go into the technical details, we see that NFV Mano do not really address the underlying network characteristics, and that has still to be solved to provide a full network slicing solution. Next slide, please. So just in summary of where we are currently, the existing VLAN, VPN, QoS, virtualization, there's many different sort of sub-angles there, but all of these are useful, but they're point solutions, so they don't really give you everything. So network slicing will basically have to look at all these from a technical point of view, but additionally build new functionality on top of that. And let's please go to the next slide, and that's what I'll talk about in terms of the IETF. The IETF, as hopefully many of you know, is the Internet Engineering Task Force. So they basically standardize, what's commonly referred to as the TCP/IP protocol stack and associated routing protocols for the actual infrastructure, and then they go up to HTTP to transport web content, and then going down the stack, they interface to lower layer functionality, layer 2 functionality. So IETF, it's an interesting observation to note that IETF just has finished some important RFCs for data centers because existing data centers were primarily layer 2 solutions, and they were very efficient, but the data center community came to IETF and basically said, we have a lot of good proprietary layer 2 solutions that are running in data centers, but we want to have an IP-based solutions that will be more standards based, and that will allow us to mix and match equipment from different vendors in our data centers. So they've gone through a big exercise, not complete yet, but they've made a lot of progress on basically standardizing what I would classify as an analogous problem, which is basically how to virtualize compute, storage, and network in data centers. And they've come up with new protocols, etc. The other point I'd like to mention is that, of course, 3GPP is the premier organization handling network slicing, I would say. We have IETF, we have ETSI, NFV, we have other standards bodies that also are working in this space, but 3GPP is leading it because really it's a 5G initiative. But 3GPP has a long history with IETF for the IP infrastructure. And the classic example, of course, in the past was IMS SIP. 3GPP did let's call it the upper layers of the applications, and then IETF did all the IP infrastructure underneath. And then another point to note is IETF is already working on a key protocol for virtualization NFV infrastructure, and that it's what's generically termed as the SFC, service function chaining. It has some related subprotocols, but basically that is the key protocol to steer traffic through infrastructure. So ETSI NFV, for example, will define the actual network and the management and operations, but when the actual user data starts flowing through it, it's all at the IP level, and that has to be handled by IP protocols. And one of the key ones is SFC to steer traffic through the network. Next slide, please. So now we get to the heart of the matter regarding IETF and network slicing. So in IETF, we've had a very active discussion a pre-working group discussion, because the working group itself has not been officially formed yet, because we're still debating what has to be done. But what some of the key points that have come up is that we believe network topology data model has to be defined clearly. Yang is the most, I guess, the latest modeling language, and so that's usually referred in conjunction with this. But generically, a network topology data model that will support building of network slices on different substrates, whether it be the lower layer could be MPLS, or lower layer could be something else. But you need a data model to be able to stitch everything together, and that's not being defined anywhere else. And then you have the more protocol-centric changes, protocol encapsulation. You might have to do some different encapsulation on different types of transport networks, so that has to be taken care of. I think a very important concept that is being debated also is that signaling to connect subnet slices. So a network slice itself might not be monolithic. I believe Maria already mentioned that it might be recursive, it might have sub-slices, and that's exactly the view that people have been talking about in IETF, that you might have sub-slices, and then you build those slices either recursively or join them to other slices to give you end-to-end macro network slice. So that all the signaling, all the protocol changes to support that still are being discussed. And then, of course, performance measurement, traffic engineering, all these sort of live operation support that you need, that's also being discussed. So in summary, from the standards point of view, specifically IETF, for network slicing to be successful, it's really important that we have both technical standards but also related industry support. Maria mentioned API and GSMA. I know GSMA have defined very good APIs for previous generations of mobile technology, and that's exactly one area I think that has to be well defined. So for an operator to be able to easily deploy a network slice, they have to be able to advertise it similarly as is done in the web world, where you have all sorts of web companies, and they just publish APIs, and whoever wants to use them can access them, can call them, and then of course there's some business relationship that's built in, either electronic charging or some other type of business relationship. But this type of industry support and infrastructure has to be there. Otherwise, we really risk the proprietary solution hole, because end-to-end, a network slice has to be end-to-end, and if we fall into the hole of proprietary solutions because we don't finish all the standards and we don't have all the industry support, then basically what will happen is that we'll defeat not only the purpose of network slicing, but nearly the purpose of virtualization. Because the whole purpose of virtualization, the business intent, was you move away from dedicated boxes, you go to off-the-shelf hardware, you go to reconfigurable software that can run in many places, and underlying all that was the assumption that you have many suppliers. So we really have to be careful here and make sure that we meet the original goals of 5G and virtualization network slicing. Next slide, please. I just want to touch briefly here on some of the related work that our company is doing, InterDigital. Of course, I participate in the standards, and we have a lot of people that also go to 3GPP. But on the fundamental research side, we are doing a lot of work specifically in European Union funded projects. And two that I mentioned here, one is Crosshaul. So they're developing basically a high-speed backhaul and front haul to connect base stations to the new mobile core. And a key characteristics of that, of course, is that it must be sliceable. And some related work is going on in IETF. Specifically, there's some definition work for this transport network, which has, for example, very tight time synchronization requirements. So these types of requirements, for example, are not met by generic solutions like MPLS. So much stricter time synchronization is required, and that's part of the work and research being done in this project, and also related work in IETF. Another area that, another research project that we're active in is Point, and they basically are developing a underlaid network fabric that will allow you to run IP traffic on top, but they'll improve certain performance characteristics for example, in edge networks like name-based routing, indirection, etc. And please, the next slide, the last slide for me. So the future trends. Network slicing, of course, we're still at its infancy, but many interesting technical discussions and standards discussions already happening about the future. And one obvious area that everyone's excited about in general is big data, also referred to as machine learning, also referred to as AI, etc. But you can see how it could easily enhance network slicing in the from the point of view that you could feedback parameters. You could feedback parameters to the network slice and make the whole system more efficient. And I use a little example here. Recently, Ericsson did a live machine learning experiment where they examined data from a big mobile network, and just by analyzing the data, I tried to identify the smartphones from the IoT devices. In this case, they found that it was primarily smartphones, 95%, and about 5% IoT devices. But you can easily imagine that if you did that sort of learning, machine learning, you could feed that information into slicing network intelligence algorithms and, for example, steer using, for example, SFC protocols, that IoT devices from a generic network slice to a one optimized for IoT characteristics, typically low bandwidth, more on the uplink, etc., intermittent characteristics. So a lot of interesting opportunities there. I think we might talk more about this during the Q&A. So now I'm going to turn it over to Sue, please. So Sue, I'm turning it over to you. I don't hear you yet, but.
Apologies, I was on mute. Susan, if you can go to my first slide. I thought it would be useful after our great panelists here have outlined where we need to get to look at where we are currently and what's coming in the very near future. And then we'll have a panel discussion to talk about how we get there. Some of the earliest innovations on network slicing came from SK Telecom. And in 2015, there was a demonstration around augmented reality and Internet of Things, which have all become even hotter since then. In 2016, Huawei worked with Deutsche Telekom to show some of the early end-to-end slicing, which did include the 5G RAN. And there have been several demonstrations which include the issue of how can I deliver quality of service over the radio access network, and especially where I have a headnet, how can I choose the right frequency, protocol, and bandwidth that is needed for my application service. As we move into 5G, as you know, is coming out as a non-standalone service with a 4G signaling overlay. The earliest demo that I know of for federated global slicing was last year at the Mobile World Congress with BMW, and Ericsson worked with Deutsche Telekom and SK Telecom to put together a multi-country, multi-region global network to show that you could do this across not just local carrier domains, but across the entire globe. And in 2000, earlier this year in May, Ericsson also did a demonstration for robotics, which may be a really good application in factory areas and for sharing control intelligence across multiple robots. One of the pioneers in addressing some of the problems that you've heard our speakers raise around administration, around orchestration and service assurance are coming out of the 5GPP, which for those of you who may not be familiar with it, is a public-private partnership which does a lot of projects that are funded by the EU under the Horizon 2020 program, one of which InterDigital already referred to. There's a project nearing its close on 5G Norma that I'll talk about a little bit more, but it's how do we really make the implementation work rapidly, and 5G Monarch, which is really looking at how do we have diverse services and use cases that all happen together in 5G in a virtual world. ZTE, as I mentioned, has worked, a lot of the Asian operators were focused very early on 5G trials and very much on the bandwidth side of slicing. But more recently, you're seeing companies like Nokia and Telefonica really start to focus on how do I actually trial some of this slicing in the 4.5G world and 4.9G world. How do I bring this and get some of the early slicing developed under today's LTE networks so that when I get the full 5G capability, I can show you how that works. And there were some nice examples of that using essentially traditional VPNs, Layer 3 VPNs, shown the week before last at the SD-WAN World Congress in The Hague for SD-WAN, a typical enterprise global network slice, where operators could for the first time, guarantee across operator boundaries, albeit with a nailed-up layered v3 VPN or an HTTPS tunnel, that you could guarantee end-to-end service quality and match both wireless and wireline could deliver an end-to-end service. And then at the end, there's a very interesting example I'll talk to you more about of Telecom Italia bridging the gap between today's 4G and 5G networks. Next slide, please. So let's look at what specifically the vendors are doing. And the vendors were the pioneers in this. Back in 2015, Nokia put out one of the first really clear papers, and the diagram's a little small, but they exemplified what a slice would look like. And they're actually showing it in 3 dimensions for smart grid, connected cars, HD video, and so on. Has an end-to-end solution that goes across multiple dimensions of the network, but is distributed and programmable. More recently, they've issued a very nice white paper on their vision of how the slices can really share a common infrastructure. And just to describe what the diagram says, is a little hard to read. The red, orange, blue, green, and yellow represent different slices, and then different VNFs or functions are replicated within each slice. And in the early implementations, what we're seeing is these are essentially separate instantiations with standalone resources for each of the logical slices, also have separate physical resources. However, in the long run, the real goal that Nokia's diagram is showing here is the goal is to share the common infrastructure so that we don't lose the efficiencies of virtualization as we move to slicing. Next slide, please. Ericsson has a similar view and has worked on some different use cases, particularly IoT and machine-to-machine communications, as well as conventional mobile broadband and very wideband broadband, as well as application, as well as augmented and virtual and really complete virtual reality. In their February paper, they really outlined 5 core functions, of which 3 of them relate to network slicing that were really needed for what they're calling the 5G core platform. So really slicing is being built into the whole evolution of the 5G core. And what you'll see on the first 3 of those is the network slice management, federating network slices, that is the multi-operator problem, and then policy and user data being available across slices from a shared data layer. As Maria mentioned earlier, Ericsson and BT recently published a very exciting paper, and we'll be happy to provide you with the link to that paper in September, on the economics of slicing versus nailing up traditional VPNs in the network to guarantee services. And inherently, it should be more economic, so that not only will new services be more flexible and be able to be guaranteed by class of service, but it should become possible to actually be able to allow new groups of users who couldn't afford to have dedicated networks to open up the market. In this example, you see that the different slices from the different applications, the cars and the wireless and the devices on the left, come through a common pipe, if you like, in the middle. Now, today, those separate slices have their own resources, and what's happening today, and Ericsson was demonstrating this in The Hague, you're having multiple logical flows with unique, somewhat proprietary flow management, since TCP/IP does not provide for flow management within the slice. So you can have multiple users sharing a common slice. And right now, that's probably the most efficient way to do it. Next slide, please. We have similarly, Huawei's been showing slicing at the physical layer for very, very high-speed connections, and a million of them, just lots and lots of connections over a common layer. And at the other end of the spectrum, they've also been demonstrating smart parking as well as the application that BT talked about earlier. Next slide, please. So let's look at how the service providers have been presenting this. And there was a 5GPP event last November in Rome and some more recent ones where NTT talked about really making this a truly software-based solution. And this is really critical to the softwareization of the telco that many of you are working on. In this diagram, they're really showing that all of the devices and all of the UEs can in fact be part of a slice, but then we can map a software UE device, can map to a UE physical device, just like you do for any other logical functionality, and that's beginning to happen in virtual CPE. Similarly, we can map any of the VNFs and the logical functions should be able to be mapped dynamically to the underlying layer of physical resources, just like anything else. Next slide, please. Verizon, however, shows a transitional stage in their reference architecture from last year. And this is probably more real for where we are today. They show 3 slices on the left, one for smartphone communications, one for autonomous driving, and one for massive IoT. And today, if you look on the right, you'll see that the 2 of those, the autonomous driving and the massive IoT, are actually using separate gateways, but then they're able to share the virtual MME environment and be able to come to the same B. So we're also, whereas separately we're keeping the smartphones and the voice calling through the conventional packet gateway, signaling gateway, and so on, and the data from the smartphones similarly. But so right now we're actually segmenting the classes of resources that are assigned to particular slices, but ideally we're beginning to share some of those, and where possible it would be ultimately desirable to have them be truly dynamic. Next slide, please. On the management side, it was mentioned earlier that MANO needs to be modified, and that some work has been going on that one. That's the NORMA project under 5GPP. And again, I put some hot links onto these slides so you can look at that yourselves. I don't have time to get into it here, but there's a complete paper and report on this, so that you can look at how we can bring MANO into this environment to do management and orchestration for network slicing. Network slice, next slide, please. Similarly, the newer Monarch program, which has a lot of participants, including Deutsche Telekom, Telecom Italia, as well as Nokia, Huawei, and Samsung, is really trying to do elastic resource slicing, mobile broadband slicing, and secure and resilient slicing. As Maria mentioned, security may require some level of isolation, but you still then need, for any one of those 3 verticals that are shown on the slide, to be able to do internet work, slice control, and cross-domain management. So some really tricky orchestration problems. And the Monarch guys are trying to actually demonstrate some of those with some pretty cool apps. One is in the Smart Seaport in Hamburg, with combining 3 different types of applications: traffic light control, video surveillance, and sensors for barges to talk to wireless terminals, some pure mobile to machine-to-machine communications. And then in Venice, there's some virtual reality and immersive cooperative media applications being used as a test bed. Next slide, please. So to bring this all together, one of the interesting presentations that was given at the Network Slicing Conference last week in London, where BT also presented some very interesting slides, so I would encourage you to look at those, or I can put you in touch with the people to get those, showing where we really are on some of these new slicing initiatives. This one is showing how Telecom Italia Mobile is trying to get to the Torino 5G initiative, which will start next year, and how they're taking a path from what they call 4G Decor, which is the abbreviation for dedicated core network that is already a standard that allows you to nail up the dedicated core functions. And DCN stands for dedicated core network in the diagram below. And essentially to pre-trial many of the slices we want to experiment with and test the business validity and the business models with a pre-assigned network core. And one of the questions I saw come in was relating to the signaling network, and the burden on the signaling network obviously is much less if you can pre-assign and pre-rate what those assigned network slices are. But as we move to true 5G slicing, indeed, there will be a massive increase in the load on the signaling, policy control. All of the mechanisms for real-time billing and dynamic reassignment come in for both the business side as well as the operations side. And Tim is working with Ericsson, as you can see from the diagrams on the right, to show how you can actually move to what they call, in the box in the middle, a 5G network where the slice is a complete logical network, and VNFs can truly be created on demand to compose the requested slice. This is the ideal. However, we have some real challenges to get there, and we're going to discuss some of those in the panel, which we're going to go to next. Next slide, please. So without more ado, and I know we're running a little bit behind on our schedule here, let me put a couple of questions to our two excellent panelists. And just to kick it off, let me ask you, Maria, what should operators and vendors be doing in this year and in next year to really prepare for this 5G end-to-end ideal vision that we're trying to get to here?
Thank you, Sue. Yeah, we think that I think one recurring message throughout the entire conversation has been the need to work collaboratively. So we believe that not only operators but vendors, a wide range of technology partners, and very importantly customers and those vertical segments that we've been talking about need to be working together to make sure that we understand not just the technology but the complexity of this ecosystem, the commercial implications of it, and all of the parts of the jigsaw puzzle, if you like, that need to change dramatically for this whole service paradigm to occur. Once the organizations need to be ready, as I said, and that requires a cultural shift to be ready to support technologies like NFV and SDN and some of the important changes that we need to perform in our networks.
Akbar, do you have any comments on how that can happen?
No, in general, I think Maria covered it well. From the standards point of view, there is definitely understanding that everything has to be compressed in terms of timelines, so we can't have the normal standardization time frame of just dragging out things. Whether the magic number is 2018 or 2019 or 2020, the time pressure is there. From the IETF point of view, we did have very good discussions with 3GPP liaison parties, and 3GPP again also stressed the timelines. So I would just reinforce that the timelines are important here.
Great. So do you see, Akbar, that we're going to really be living for a while, though, with these predefined network slicing with service parameters that are relatively static and optimized for particular categories of service, while we wait to figure out how we're going to define more dynamically defined network slices?
Yes, I do believe that the initial deployments will be predefined. And of course, we have the classic use cases that came out of 5G that drove a lot of 5G. You might have one network slice optimized for IoT, one network slice optimized for what's called mobile broadband, meaning video and other high definition, high bandwidth traffic, usually on the downlink. The IoT is of course on the uplink. And you might have public safety or low delay requirements. So I do believe that these classic use cases will be the ones that will be first deployed, and the slices will be optimized for those classic use cases because the parameters are very well known, as I mentioned, whether it be uplink, traffic characteristics, or downlink, or bandwidth, or delay. I believe that's a logical place to start. And then going forward, if we believe in this trend of machine learning and big data, which I think has a lot of good indicators that it will be successful, then you can have more dynamic, more let's say elastic network slices that come into being as required. Of course, the other part of that is some business relationship has to be available there. So the operator might have the most dynamic network slicing system available, but if they have no way to advertise the APIs, if they have no way to charge for it, so I believe the mobile operators will start becoming like Amazon and Google, where they offer APIs and basically a credit card or some other electronic charging system.
Maria, would you care to comment on that?
Yeah, no, I can agree with that vision actually. In opening APIs for people to consume slices from our networks. I personally don't believe that they need to be predefined or standardized anywhere. We believe in flexibility and innovation in this entire system, and therefore we believe we need the mechanisms to achieve that. However, we do need a common way of describing what a slice may or may not be able to do. And to that, we do believe that there is a need for industry to get together and define that, which I mentioned during my presentation.
So maybe just as a last question, and then we're running a little behind time. But Maria, do you see some big gaps? And one of the challenges I see is that inherently the TCP/IP that IETF is working on was never designed to do either flow management or end-to-end service guarantees. And do we have to take some new approaches like some of those that MEF or the ETNGP people are looking at with architectures like RENA? Are there some new ways we need to really start to rethink how we do end-to-end networking?
I think for the long term, we're going to definitely have to think about all that, and we know that there are a number of activities looking at that. Being realistic and pragmatic, we probably won't have those solutions available by the time we need to start deploying these solutions. So there's probably going to be a gradual adoption, if you like, of all of those more radical approaches. But yeah, absolutely need to start working on those now to make sure that in the long term we have that more suitable approach to those services. I don't know if Akbar has some comments on that, by the way, because he's probably closer to some of those activities than I am.
Yeah, do you have a final comment, Akbar?
Well, I'd like to get into detail, so maybe we'll just park it for now.
Okay, so let me hand it back to Susan Welch-Grimaldo to wrap up.
Great, thank you, everyone. And I had a couple of audience questions. I'm going to go ahead and ask one of those as we do our wrap up here. But there was a question for Akbar, because he mentioned some of the inadequacy of VPN and QoS in the layer 2 and layer 3. And looking at that Verizon architecture view, there was really one question, the example there that showed sort of the CP/UP split. And the question was really who's addressing these gaps and issues, and how are we doing this at this point?
That's a good question. Part of the gaps are being addressed in IETF for the underlying network. So I mentioned time synchronization. That's been identified as a key problem, because for the front haul and the back haul, because we're talking about radio interfaces where timing is critical, because it's tied back to the air interface where layer one synchronization, etc. So some of those issues are being addressed in IETF, definitely, but IETF is also working. I mentioned 3GPP several times, but they're also working with IEEE. So there is also IEEE activities to define a new next generation time synchronized lower layer, in the 802.1 family. So those, although I think all those different standards, starting from like layer 1, layer 2 technologies done by IEEE, then IETF does layer 2, layer 3, layer 4, and then 3GPP, from our point of view, sort of is the applications on top. They're all working together. No final solution is yet available that I can point to, but I think people are working incrementally on all the pieces, and they're well coordinated, the solutions.
Great, thank you, Akbar. And I think we'd like to wrap up today with really calling here for a call to action. We've seen, as you can see from the discussion today, a lot of significant progress being made on network slicing requirements, both from a technical perspective and from a more business-focused approach. But there's still a lot more that needs to be done on the approaches and standards as we move towards getting to commercial deployments on 5G networks. It's one of the questions I think from the audience came in, that it really isn't even a full agreed upon definition of slicing yet, and lots of discussion around the parameters and how to actually make some of these end-to-end things happen. So some of the things we really need to see done in the next 2 years are testing network slicing under LTE. And so we talked about this with some of the activity happening. Really look at some of the flow management and shared virtual resources. Obviously, the automation there is key to start getting some of this much more cost effective. Preparing for dynamic end-to-end network slicing for 5G, really, we saw lots happening, but more needs to happen. And particularly then as well, really, how do you do the SLA guarantees, make those a reality? I think there was a question on that, and I think that's certainly something that's, we had some discussion on. Something that's still being worked on is exactly how is that going to happen. So please follow up with us, any of the panelists, afterwards if you have further questions on that. And so some of the new approaches, ecosystem collaboration and standards are needed. We'll need real-time application, service level allocation by class of service. As we said, the ability to really do the dynamic end-to-end slices in the network to ensure SLAs can be guaranteed, and to develop business cases, which is where we really need to see a lot more participation and collaboration across ecosystem. We're seeing a lot of activities happen. I think the telecom infra project is also starting to work on slicing. Other areas where we're seeing additional work to pull in ecosystem partners and try to make this happen, to make sure those business needs are met. And some additional information, as part of this research effort we've been doing strategy analytics here with RCR, we also did, one of the other sponsors was Intel, and I did 2 series of video interviews with Dr. Gungwu and Carolyn Chan of Intel, and I encourage you to follow those links and look at those as it's just going live. Some additional really good comments that I think you'll find very valuable. And then we will be publishing strategy analytics along with our CRA report that will be available to everyone on the same topic of looking at unlocking 5G revenue potential with network slicing. And as we mentioned, the slides and the link will be available to all the participants. So with that, I'd like to thank Akbar and Maria and Sue for their participation, and RCR for hosting this. And thank you for joining us today.
Thank you.